Hi, my name is Mackenzie. I'm a member of Meteorite Group 3, and with our presentation, we look to answer the question, can a site be determined to find lunar meteorites in Antarctica? NASA looks to leverage meteorites as tools to better understand the beginnings of the solar system and to benefit ANSMET's endeavors. The subjects of analysis are lunar meteorites. Lunar meteorites are feldspathic rocks, basalts, and mixed breccias that are characterized by their unique textural and chemical qualities that define them as lunar. To begin the work, Meteorite Group 3 analyzed multiple Antarctic discovery sites to conclude which site provides the ideal conditions for lunar meteorite discovery. This data was then utilized to compose graphs of the sites with the percentage of meteorites discovered at the respective sites. A conclusion was then formed regarding which site would be ideal for meteorite discovery.
The study of meteorites and their components is integral to a greater understanding of our ever-changing universe. NASA and its constituents recognize the importance of the study of meteorites to both NASA's exploits and to science as a whole, and it is due to this acknowledgement that NASA often collaborates with programs such as the Antarctic Search for Meteorites, also known as ANSMET. ANSMET is a program led by the United States that works to recover meteorite samples from Antarctica. These samples are distributed among scientists and researchers alike in an effort to uncover truths about the materials that make up asteroids, planets, and other bodies in our solar system. Our group has been studying ANSMET's findings and objective collection data, specifically their research on the collection of lunar meteorites, in order to determine an answer to our guiding question. Can a specific site be determined to find lunar meteorite samples in Antarctica?
In order to determine a potential site likely to yield lunar meteorites, Meteorite Group 3 analyzed meteorites collected by ANSMET. The ANSMET team has found many meteorites in Antarctica, 32 of which have been identified as lunar meteorites. The map shows the exact locations the lunar meteorites were found by ANSMET on a variety of ice fields. However, they are grouped first by the overall site they were found at, in accordance with ANSMET's conventions, such as the Dominion Range or the Allen Hills. The data was further grouped using the pairings identified by researchers at the NASA Johnson Space Center. Two meteorite finds are paired if they are believed to be related. For example, if they were the same meteorite that broke apart before being found. This cleared up some potential errors in the findings. For instance, there were 7 meteorite finds in the Dominion Range, but only 1 meteorite pairing. Thus, it is not as good a place to search for lunar meteorites as the Miller Range, where 6 different pairings have been found.
We reorganized the data collected so that the pairings would be recognized as one entity instead of each individual meteorite sample. Once the data was reorganized as shown on the right, we found that the middle ice field had the greatest number of lunar meteorites found. The middle ice field is part of the Miller Range along with the northern ice fields and Marsh-Side Glacier, where another 3 lunar meteorites were found. The data in the form of a pie chart shows that lunar meteorites had the highest frequency of being found in the Miller Range.
Currently, the lunar meteorite collection from ANSMET is very limited, with only 32 meteorites including pairings. Having determined sites with greater chances of collecting these specific meteorites could allow for more research on the Moon's composition. The majority of lunar meteorites curated have either aneurystic or basaltic-based compositions, which are both very common in Earth's crust and mantle. Analysis of these meteorites and future meteorites could help determine the history of Earth's only natural satellite.
Using the data collected by previous ANSMET expeditions, an optimal site for a lunar meteorite search has been selected. However, there was only a limited amount of data on the lunar meteorites. Around 33% of these meteorites were found in the Miller Range, specifically in the north and middle ice fields, as well as the Marsh-Side Glacier. A variety of different meteorites, such as feldspathic breccia, and other types of lunar meteorites were found here. With that, the conclusion is the Miller Range is the best location for ANSMET to conduct its next lunar meteorite search.
The links on this slide are the sources that we used in making this presentation.
During the internship, everyone from Meteorites Group 3 had a positive experience because of the opportunity to listen to professionals in the field, learn about potential careers in STEM, and work with great teammates, as shown in the quotes.
We would like to acknowledge and thank the following mentors, speakers, and collaborators for their gracious support of our project. These include the NASA Texas Space Grant Consortium, Margaret Baggio, Selena Miller, Kellye Pando, and Suzanne Foxworth, and all of the NASA Ares and Sea speakers. Thank you.
Thank you for listening to our presentation. We would now be glad to answer any questions.